Hello and welcome to episode 66 of Daryl Show Your Work. So in this episode, I'm going to be reeling it back a bit again, and be discussing basic digital forensic techniques. So this is not supposed to be a deep dive into a very complex subject matter within cybersecurity, but more of a high level overview of just some basic techniques that we can do, and, forensics related techniques that can be done in order to prevent data exposure and to catch things fairly early in the process of within the MITRE attack framework, and also as far as preserving evidence in case we're looking at legal or criminal cases. All right. So the first subject matter that I wanted to discuss was hashing. And if we think back to the video that I previously did before this one, where we had that PCAP file that was exposed to the outside, well, that even if it was exposed to the outside, what could have been done is we could have actually encrypted that file. So even if an attacker somehow got it through some other means of it not being publicly facing or through the same means, well, they would have gotten just some unreadable ciphertext instead of plain English credentials, or a password hash that they could easily crack. So a way that we can do that is we can use a hashing function. So what that is a one-way encryption method to ensure the integrity of a file or a communication. So let's say if even one character is changed in something that's hashed, the hash value completely changes. So if I were to add like a period or to like one area of whatever that is, of whatever that file is, communication is, well, or if I were to take something out of it, well, it would completely change change how that ciphertext looks. Like, even if I were to capitalize something in it, it's going to completely change how that ciphertext looks. All right, and so that's going to help us enforce what's known as non-repudiation, and to verify data integrity and to detect any sort of alterations. All right, so I'm going to um, I'm going to display what that looks like here. All right, so the first thing I'm going to do is use the touch command to create a dummy file, which I'm going to name file one. All right, and then in order to well, I don't need to sudo this. In order to hash this dummy file, let's say I want to use the hashing function SHA-256, which is pretty strong. All right, and I need to say sum, and then I'm gonna say file one. All right, so this is going to encrypt file one with the SHA-256 hashing function, and we're going to see the output of that. All right, so as you can see, that is showing us the ciphertext that represents file one. All right, so if an intruder were to somehow download this file, okay, all they would see is the ciphertext, and because SHA-256 is pretty strong, they wouldn't be able to easily crack it as they were as I was yesterday when I retrieved that password hash from our data capture. All right, so this is an example of hashing, and how files can be hashed as a way to obfuscate their nature. And it's also a great way to preserve evidence in a case it's needed for some sort of legal case, or a criminal case, or etc. All right, so the next subject matter I want to jump into is interception. And so basically, interception is exactly what it sounds like. It's monitoring network traffic to be able to find anything anomalous that we would need to jump on immediately before it escalates any further up the MITRE ATT&CK framework. So we want to be able to catch like scans, or in the case that I'm going to be jumping into in a few minutes, is clear text protocols. Okay, so the application that I'm going to use to show how we can intercept network traffic is using application that I've used in previous videos called tcpdump, which is a command line utility for capturing and analyzing network packets in real time. So think of it as similar to Wireshark and the command line based brethren of Wireshark. All right, so to uh, to get started using TCP dump, let's say that I just wanted to use TCP dump just to clearly see all the active interfaces that were up and running. All right, so I'm going to say TCP dump dash capital D. All right, so that gives me a full list of I mean, just all the interface available interfaces here. So we can see that we have three that are actually running, which is ENS 32 up and running, low, which is of our loopback interface, which is up and running, and then we have any, which is a pseudo device that captures all interfaces, that's up and running. So it looks like Docker zero's up, but it's not running, and then we have a Bluetooth, an NF-log, and an NFQ interfaces that are not up or running, but they are present. All right. So let's say that I wanted to see what TCP dumps packet capturing function looks like. So let's run this since ENS 32 is up and running. Let's run it on that. All right, so I am going to need sudo to start up this aspect of TCP dump. All right, and then I want to say a -I to specify the interface that I want it to run on, and then I'm going to say ENS 32. All right, and this again, what this is going to do is going to capture and analyze all data on that ENS 32 interface. All right, giving it my password. All right, and that's going to just keep going and going and going because I didn't specify any means for it to stop. So um, if I want to do that, TCP can be executed with a time limit if used with a Unix command called timeout. I can specify a seconds with the S flag, and if let's say I just put a number in a command line where it's going to use that second parameter by default, and so it's going to measure any number I put on there by seconds and not by anything else. Or I could use a M flag, which is for minutes, and H flags, which is for hours, and a D flag, which is for days. All right, so to show what this looks like, I'm going to open up another terminal window. I'm gonna just let this do its thing. All right, maximize this for us. All right, so if I want to see what it looks like to time out TCP dump, I would just say sudo. And actually, what I'm going to do is I'm going to time it out, but I want it to write into a to a file too. All right, so I'm gonna say sudo, and I'm gonna say timeout, and let's say 20. Okay, so because I don't want this to be too long of a video, so I'm gonna say 20, and remember 20, if I don't specify any flags, it's going to measure that by seconds, so it's only going to run for 20 seconds. I'm gonna say TCP dump since that's the application that we're using. I got to specify my interface here, ENS32. All right, and the -W to write. All right, and I want it to write the output of this to my home directory into a folder, my user folder, ubuntu user, and then I wanted to save it as a file called data.pcap. And for those who know what a pcap file is, you already kind of have a feeling where this is going to go next. But hit enter. No spoilers for those who don't know. All right. So give it a chance to run, and it's going to save that capture to that data .pcap file. All right. So it looks like it was able to capture 871 packets for us. So and now I'm going to move on to the analysis phase of when it comes to digital forensics and how it is that we can analyze packets. So for this, if you haven't figured it out yet, but given the name of that output file, I'm going to be using Wireshark in order to do this. So we're not going to be we could use Wireshark for interception, but we're not going to be using Wireshark for interception in this video, but instead we're going to be using it for analysis, and that's why I'm going to boot Wireshark up with this new data.pcap file, because we want to be able to look at the previous packets that were captured and not necessarily intercept any sort of packets that are actively being passed through on the network. All right, so in order to do that, I'm going to say Wireshark, and then I'm telling it to boot with that packet capture user. All right, and it's data.pcap. All right, so this is going to cause Wireshark to boot up with this pcap file that was just created from the latest TCP dump capture. All right, so I'm going to maximize this for us. All right, so we see we have a lot of traffic here. Again, 871 packets. I'm not going to try to weed through this to find something anomalous, but what I will do is we see some Telnet traffic here. So I'm going to zero in on this, and I'm going to put in a filter here, and let me write this in, and I'm going to explain to you why I'm picking on Telnet here. TCP port equal, and telnet is port 20. Well, needs two equals. Hold on. All right, telnet is port 23. All right, so I'm gonna hit enter. All right, so we have nothing but port 23 traffic, which is a telnet. All right, so the reason that I single telnet out is because it is a clear text protocol, and if I'm doing analysis here and I see that a clear text protocol is in use, I want to observe this traffic to make sure that no clear text sensitive information is being passed through the network here. All right, so I'm going to right click on this first packet here, and I'm gonna go to follow TCP stream. All right, we got us a problem right up front. All right, so if we look at the Ubuntu login, we can see the login ID, and then we can see the password. So this is why this is a problem. This looks very similar to my previous video where we encountered something similar, except fortunately and unfortunately, the password was hashed, but it was hashed using a very weak algorithm, which I was able to break within a few seconds. But this is just giving us clear text credentials, which um, we um, we never want. So the use of Telnet over the public internet should be avoided due to the risk of eavesdropping on this sort of information. So um, I would say after identifying the clear text telnet communication such as this, it should be replaced with something such as SSH for encrypted remote access. All right, so that's the if we were to discover something like this, we would go about having this protocol replaced with something again safer like SSH, because that traffic would then be encrypted instead of plain text such as this. All right, so I want to show another example of why this is so potentially dangerous. All right, I'm gonna show another packet capture. Let me open up a new window here. All right. So I'm going to go to another packet capture here. I'm going to say cat, and this one just has a single packet in it. But what I'm going to show it is an example of how clear text why clear text exposure is potentially dangerous, and I'm going to show like how sensitive information can be exposed if in the wrong hands. So I'm going to hit enter here. All right. So you see how what you see here is an operating system and a version. All right. So if you have an intruder that were to come across this plain text file with using a plain text protocol passed across the network, and they were to eavesdrop and download this file, well, they would be able to see that, well, at least somebody in our network is using this operating system with this version, and we've done some of their enumeration for them, and they could be able to find specific vulnerabilities or specific exploits that target known vulnerabilities to this particular version of Ubuntu. All right, so that's another reason why the file should be encrypted using a hash mechanism, and also why the inside of it should also be encrypted as well. All right, so if I go back in Wireshark here, all right, let's see, there we go. All right, another thing that I wanted to point out, I'm gonna use a different filter here. All right, so I'm gonna say um, see TC contains login. All right. All right, so what I did by entering in that filter, so this narrows down all the traffic that we saw to just authentication traffic, and we just see a ton of authentication traffic here. All right, so I'm going to right click this first packet here, follow it, and go to TCP stream. All right, so we see the same, pretty much the same thing we saw before, but I wanted to point out something else here. If we look at this welcome banner, all right, this tells us that, okay, that these credentials were not only passed through, but then then we got a successful login. So again, if I'm an attacker and I get a hold of this packet, I can see that this username and this password is valid and will get me a valid session into whatever device this is using the Telnet protocol. So again, um, this is very problematic, and this was done by we can see that whoever this is at 172.20.111 was able to do that. Now, whether this is malicious or not, we don't know. I didn't dig that deep into the investigation to really see if this is a malicious outsider, or if this is a valid login with somebody with a valid user on our network. But again, Telnet shouldn't even be used for these reasons. All right, so we shouldn't be giving the attacker all of this information here. All right. So the last thing that I want to touch on, I'm going to circle back around the hashing and wanted to take this example here in ways that we could once we found this data capture and we let's say we want to save it. If I wanted to prevent an incident like I showed in my last video, of course the first thing we would do is we would remove the PCAP file from public exposure, but then the next thing we would do in case it was somehow found and downloaded by some other method, we're going to then hash it. So I want to show some other ways in which we could hash this new data PCAP file that I have. So let's say that I wanted to hash it using an MD5 um, function. All right, so I'm gonna say MD5 sum and just give it the location of that file. Let me go back. There we go. All right, and it should give me a MD5 output. All right, so we have us a MD5 encrypted version of data.pcap. But the problem with MD5 is that it's a very weak hash function, and it can be easily cracked. It has known collisions, which is another way of saying that it's been known to create duplicate hashes. And once that happens, then what's inside of it can be easily exposed, and so it doesn't have a lot of variation um, with its output. So let's use a stronger method, all right? So remember in the beginning of the video, I used the SHA-256 method. I'm just gonna say SHA this time, all right? And I'm going to show you that how depending on, as you can see here, depending on what method of of hash encryption we use here, shows the difference in how the output looks for the same exact file and the length and things of that nature. So um, the output and how it looks will vary from algorithm to algorithm, length, values. So it's not you're not going to get the same value based on regardless of what um, um, the hash function you use. They're going to vary from function to function, and as far as length and as far as the actual values themselves. And and again, I could have said SHA-256 here. I could have said SHA-2 512. Those are the amount of bits that is being hashed with. But by default, if I just put SHA sum, it's going to encrypt it in SHA-1. So of course, I would want to use something stronger, but I just wanted to show an example of me being able to encrypt our new file in different with different hash functions and how they vary in terms of look and length. All right, so that brings me to the end of my video. I wanted just to keep it real basic, just show some basic digital forensic techniques in terms of hashing, interception, and analysis as a way to preserve any incident, preserve any evidence of an incident, to be able to intercept any sort of anything that doesn't look right or anything that's in clear text, the things that should not be in use, and then to be able to analyze that traffic to be able to tell if there's a real problem going on as far as authentication by intruder or being able to analyze a potential problem, even if done legitimately by a legitimate user, to be able to see how that scenario can be problematic if it was not a valid user in our system. All right. So please like, subscribe, and please like, subscribe, and share, and most importantly, show your work. And it's till next time. Take care of yourself, and God bless.